Good day, everyone, and welcome to the second week of the differential equations class. This is what we are going to learn today. So mostly it is about solving some particular classes of differential equations. And so separable equations and linear differential equations. Here is the list of things that you're supposed to know in order to understand today's lecture. This is very important. So if you, forgot how to do integration, please stop the lecture and review. It is important that this lecture is mostly handwritten, so I'm going to go through a lot of worked examples. Okay, so you really have to watch the video to understand it, because the slides themselves, they do not have these examples. They do not have the workings. Okay, the first class of differential equations that we are able to solve explicitly is called a separable differential equation. And so separable differential equation is a differential equation, first order differential equation, where the right hand side can be expressed as the product of a function of the dependent variable and the function of the independent variable. And so here are a few examples. And so here this t is our a, and this sign is our b. Okay, so here we have dy dx, right? So now x is the independent variable, so this is our a of x, and then we can write that this is times 1, and this 1 is going to be b of y. Dy dx equals 0.01 y, right? So now this is our f a of x, and y is b of y. So here the whole thing can be thought of as, well, now the dependent variable is v instead of y, so this is going to be b of v, and then we can write times 1, and then 1 is a of t. How do we solve a separable differential equation? Let me go through an example first, because it is best explained on an example. So it is actually a bit funny. Right? So as the name suggests, in order to solve a separable differential equation, you need to separate it. So how do we separate it? We move everything with the dependent variable on the left and everything with the independent variable on the right. Right? So in other words, what we really need to do, we need to divide our differential equation by y square. So then y square moved to the left. And then we need to multiply our differential equation by dt. And then dt is moved to the right. So by doing this, we are going to get the following. Dy over y square equals cosine t dt. Whatever that means. Of course, it's not really a true equation, and we are not, strictly speaking, we should not just divide by or multiply by dt, but let me explain how the method works, and then I will prove that it is actually correct. But then what we do is we just write an integral sign. Okay? Well, now let us integrate. The antiderivative of 1 over y squared is 1 minus y, minus 1 over y. The antiderivative of cosine t is sine t. Well, and let's not forget the plus constant. So plus constant. Okay. Now let us just solve it for y. So if this is minus 1 over y, then y is going to be minus 1 over sine t plus constant. Well, but then you probably noticed that when we divide by y square, of course we need to make sure that y is not 0. So what if it is 0? Right? So what happens if y is 0? Because when we divide by y square, y is not allowed to be 0, but in the original differential equation, it may be. Well, so let us just check if y equals 0 is a solution of the original differential equation. Right? So let us substitute it to the differential equation, to the original one, and well, see if it gives us a correct equality. So d0 dt equals 0 square times cosine t. Is it correct? Yes, it is correct. Well, and since it is correct, it means that it means that y equals 0 is actually a solution. So the answer is or y equals 0. So the final answer is that either y equals minus 1 over sine t plus constant, or y equals 0. Now, with differential equations, usually it is a very good idea to verify your calculations. So let us verify. So now we're not going to solve it. So now we already know that the solution is 1 minus 1 over sine t plus constant. Now let us verify it. Right, so if we let this be y and substitute to the differential equation, then the left-hand side of the differential equation is the derivative of y. Right, so the derivative is minus 1 times, then we differentiate 1 over something, we get 1 over this something sine t plus c squared, and times minus 1, and multiplied by the derivative of sine t, which is cosine t. Right, and then notice that minus 1 cancels out. Then the right hand side is y squared. So let me write minus 1 over sine t plus constant. This is our y squared times cosine t. Well, this is clearly the same thing. So it's the same as the left hand side, which means we are done. Right, so we have verified that this is indeed a solution of our differential equation. Okay, so this procedure is, strictly speaking, is not necessary because we have found the answer, but it is, well, very advisable. So if, say, on the midterm test you have some time to verify your answer, then you can do it. And so it is a good idea to do it. I will write advisable. Advisable, but not necessary. Notice that before I explained why the method works, we still don't know, we cannot be sure that by doing this we have found all solutions, that minus 1 over sine t plus constant or